Today we're going to expand upon the concept of right triangle trig, the sine, cosine, tangent, fun stuff, by looking at something called an angle of elevation and an angle of depression. They will come into effect mainly in word problems that allow you to set up different scenarios depending on what we want to calculate. Okay? So, here's the first thing. That's you. And if you look straight ahead, you have this line. Anywhere you go from that line upwards is what's called an angle of elevation, because you're going from the horizontal line and you're elevating your look upwards. Anytime you go from that horizontal downward, it's called an angle of depression. Okay? Everything comes from that horizontal line. You go up, it's elevation. You go down, it's from depression, or it's called depression. Simple concept, yes? Good. Now, all I got for you are some examples. Here's the definition. We did that already. Here's the other definition. We did that already. Here's the first example. I would suggest you start by drawing a picture. Get out of the way. After reading that problem, or that question, there is a piece of information in that paragraph that you don't need. What piece of information is not needed? 30 feet. Yeah, we don't care how long the ladder is. What we care about is how far you can extend the ladder. So we have 25 feet and we have 6.5 feet. Everybody got a picture?
No.
Why not? Were you having trouble with the big words?
Yeah.
Which word was giving you trouble? The T-H-E?
No, T-O.
Taha. Payant. Kriu. Pas. Parut. Hasid. Nani. New. 30 extension. Laid. Tahi manufacturer. All right, draw a picture, calculate the angle. Let's go. You're smart fellas. You can do it.
Okay, wait, I'm kind of lost. Just a little.
Bust out those calculators. Make sure it's in the right mode. You never know. Your friends may have been messing with the old calculator.
You might want to check your calculator.
You don't want to be that person that shouts out an answer that's wrong because you're radians instead of degrees.
You use the inverse. Wait, I'm scared.
You may also want to ask yourself, what's a reasonable answer? So let's suppose I get an answer of like 15 degrees. Does that make any sense whatsoever? No, no one sets a ladder up at 15 degrees. Would 90 make any sense? No. Who puts a ladder flat up against the wall? So it should be somewhere a little bit more reasonable. Will it be bigger or smaller than 45? Bigger.
I'm confused.
Whoa, that's a mess. The other assumption we have to make is that the building is perpendicular to the ground. That's a pretty safe assumption, unless it tells you otherwise. Here's my picture. Stop what you're doing, look up here. Where's the 25 go? The ladder, which is the hypotenuse. Good. Where's the 6.5 go? And then you've got an angle. What do you want to use the angle? Well, we're all big people now, so it's time to learn your Greek alphabet. We're going to use theta. For those of you that can't see that, a theta is a circle with a line through the center of it. The couple that you should know, I'm not going to teach you the entire Greek alphabet, but I am going to show you a couple you should know. Theta, alpha, beta, and gamma are 4 that you should know. Alpha, fishy. Beta, fat bee with a tail. Gamma, fishy on its head. Those are lowercase Greek letters, and they're commonly used to refer to angle measurements. How we doing so far? Rebecca, you got an answer?
Yep.
Do tell.
So, theta would equal 74.1.
Can somebody back that up?
Yes.
Awesome. Could you tell me what equation you set up, please?
So I did the inverse cosine.
Well, let's start from the beginning. Just start up your trig, and then we'll work it through for people that aren't with us.
Okay.
Go ahead.
So, since I set up cosine of theta is equal to 6.5 over 25.
Whoops, 6.5 over 25. Well done. Cosine is adjacent over hypotenuse. I know the adjacent side. I know the hypotenuse. How do I get theta by itself?
I multiplied everything by the inverse cosine.
Okay, just technically speaking, you didn't multiply it by, you took the inverse of both sides, but splitting hairs. If I do it to one side of the equation, basic rule of algebra, I have to do it to the other side, and look what I did. I was so smart I left space in there. Not as dumb as I look, you know. Hey, Rebecca, what happens when I take the inverse cosine of the cosine?
It doesn't do anything.
Can you say that a little bit more eloquently? Say it with a British accent. That'll sound so much more eloquent.
Theta remains by itself.
Outstanding! I noticed you went with the dignitary British accent instead of the Cockney accent, yeah. That's right, Lisa, say to that by yourself. What'd you do on the other side?
I took the inverse.
So we're done with the accent now? Is that it? You just thrown it out? Okay, good. You're only good for one accent? All right,
I took the inverse cosine of 6.5 over 25.
good. Plug that in your calculator, grind it out. You said 74.93 degrees. Well done. Okay, any problems? Beautiful. Just for giggles, how big is that angle? Let's call that alpha. Yes. How'd you get that?
I did set up some, I called it X. What is it called? Alpha?
Alpha, yeah,
Okay.
or fishy.
So I did sine of alpha equals 6.5 over 25 and then I took the inverse.
Perfect. Excellent. Too much work though.
Or, okay, well I found that one first and then,
Ooh, okay.
and then I added a lot of.
Did you misunderstand the question?
I just did them both.
You're feeling saucy and
Yeah.
just figured I'd watch me, I'm gonna do both?
Yeah.
Awesome. Okay. What's the practical way to find alpha? Subtract it from 90. Okay. Part B. How do I find this? Let's call it h for height. How do I find h? 2 ways, 3 ways, 5 ways, 7, a couple ways. Michael. Beautiful. Pythagorean theorem. Set it up for me just to make sure we're all on the same page.
6.5 squared plus x squared equals 25 squared.
You got like a sexy voice. What's with that? Are you sick?
Kind of like,
I'm sorry, what?
Wait.
It is kind of very raspy. Are you getting sick?
I feel bad for him. Let's all talk in that voice today, okay?
So, one way to solve the problem is use Pythagorean theorem. How else can we find h?
Michael? Come on.
You can't do that, please. It sounds like you're important. You could do the cosine.
Oh, alpha or theta?
I can't hear it.
use the cosine of alpha and do h over 25. Good. You can do the tangent of theta, right? Tangent of theta would be h over 6.5. We could do the sine of theta, h over 25. Any one of those would give us h. Which one is preferred?
Doesn't matter.
What's the more correctest? Pythagorean theorem why? Can't continue like this.
It's more accurate.
It's more accurate, correct. Unless you get crafty and you store this. Okay, now the problem is there's no theta button on your calculator. So you might want to stay away from the Greek letters. But, well, there is, I know, but to get, okay, don't start with me.
How do you
But you won't, it would take a weekend to teach you how to bring up theta. So just, how do you?
How do
you get there?
That's 4 times now. One more.
Okay. I can't.
All right, good question. What is h, by the way? 24.14? 24.14 what? Feet. Okay, so notice these are word problems, so they have units now. The angle is measured in degrees. Put the little degree symbol in there. H is measured in feet. Include the units for feet. Anything tough about that?
Yes.
Beautiful. Let's move on then. Okay, there's another one. Draw a picture first, it will make your life a lot easier. And be careful when you draw the picture, because if you don't draw the picture accurately, it's not going to make your life very much fun. This is the first time we introduced this concept of angle of depression. We had an angle of elevation in the last problem, but I don't think I addressed it that way. But now I use the phrase angle of depression. You don't have to draw your boat that accurately. Or, sorry, it's a ship. I'm sorry? So you're out on the ocean, you're like, hey, here's where I am. Let's see what the average depth here is. My chart says it's 40 meters. It's accurate, ain't it? Okay, ready?
Nope.
No?
Let's just go.
Some panic.
I don't know how to stop this. Wait, what do you
You just did that. Anybody got an answer? What do you got?
I got x is 8.5 meters.
What are we looking for?
The
Our lowest average given how far it's average. Okay, good. I don't know if that's the right answer, but we'll find out.
yeah.
Okay. Ocean. Boat.
That's not it.
That's a great flow.
Thank you. Angle of depression measuring 12 degrees. So the horizontal in this case would be the ocean. The angle of depression would then be downward from the horizontal. So we'd have it down like this. That's 12 degrees. Here's the ocean floor. Where's the 40 go? A, B, or C?
B.
B. Now, let's pretend you're hanging out at the wreckage. You're down here. Notice that the angle of depression from the boat to the wreckage is the same as the angle of elevation from the wreckage to the boat. Does that make sense? Why is this angle also 12 degrees? What's they?
Angle 12 and
No, lines can't be parallel. Or sorry, angles can't be parallel, lines are parallel.
the top of the ocean and the ocean floor.
Right, we're assuming the ocean floor is level here, which is a safe assumption. This top of the water is parallel with the bottom, so these are alternate interior angles. X or Y? Which one are we looking for?
Y.
No,
S.
X. Right. Because what we're going to do then is we're going to drop a diver out of the boat. He's going to end up there, and then he's going to schlep his way along the bottom of the ocean to get to the wreckage. Because we don't like the diver.
Why not?
Because
Seems cool.
no, he's not. He's not. He seems cool, but when you get to know him, he's not so cool. And plus, we're concerned about his well-being. He doesn't get enough exercise, so we want him to get out and elevate his heart rate a little bit. If we just dropped him, then he'd just be like,
Is he like heavier, so would he like sink?
no, he's not heavy. He's, you know, he's,
Just like average.
I'd call him husky. He's, yeah. He could use a workout.
Okay.
You know what I'm saying?
Well, yeah.
Yeah.
Okay.
So we drop him and he walks across. That is a great question though, but then again, if we parked the boat over that, we wouldn't have a question to ask, it would just be 40. Or no, 0 would be the answer. He would land right on top of the wreckage. What'd you say the answer was?
8.5 meters.
8.5 meters
I
does,
think I drew a picture already.
I think he did too.
I got like 0.0.
I said a
So if we look at this, and notice when we set up these angle of elevation and angle of depression problems, we actually get a rectangle here. You can solve this triangle, or you could solve this triangle. We're going to solve the original triangle that we used to set up the problem. What function do I want to use?
Tangent.
Tangent. So the tangent of 12 degrees is equal to 40 over x or x over 40?
40 over X.
40 over x. Whoops, 40 over x. How do I solve that?
Multiply by x.
And then divide by tangent of 12.
Also known as the switcheroo.
That's supposed to be tangent.
What?
That's supposed to be tangent under the 40.
Yeah, it clearly says tangent. Are you blind? What's x?
188.19.
188.19 meters. As you can clearly see. That seems a little reasonable.
Yeah.
Because that angle's really tiny, and so this distance would be, that's pretty rough though. We're making that diver schlep along the bottom of the ocean, almost 2 football fields. But again, he needs to work out. I'm over it. You guys over it? Great. Let's go.
Okay.
Let's move on. You can see that in these word problems, the most difficult part of the word problem is getting the picture correct. Once you get the picture correct, then we just resort to a standard right triangle trig problem where we just have to pick our, whoops, wrong button. We just have to pick our, let's try that again. No, yes. Yes, there we go. We just have to pick the correct trig equation and set it up. This one, not so easy. You're gonna need some help on this one. Okay. So, angle of elevation from Lone Pine to the top of Mount Whitney is 10 degrees. John, traveling 6 kilometers straight from Lone Pine along a straight level road towards Mount Whitney, finds the angle of elevation to be 22 degrees. Okay, so here's what's going on. Let's start with a big chunk. Let's just click on the button to make it to the next slide. This technology is wonderful, isn't it? Okay, big, long, level ground. Here's the mountain. There's the top of Mount Whitney. I can't get into the mountain to measure that distance, so I'm going to use the information that John gets for us to figure out the height of that mountain. What would you like to call the height of the mountain?
Hey.
Thank you for all those viable solutions. I'm going to use H. Because H stands for, no, happy. Here's John. He measures the angle to the top to be 10 degrees. We have no idea how far John is from the very center of the mountain. He could measure this distance up to the edge of the mountain, but that won't do anything for us because it's a mountain. Who cares? We need to go to that distance, but we can't figure that out. So he just measures that elevation and gets 10 degrees. Then he backs it up. How far does he back up? 7 kilometers. And measures the new, oh no, I did this backwards, didn't I? John travels it, oh be quiet, along a straight, towards Mount Whitney. Got my angle measures wrong. Yep. That's why they make erasers. Whoops. That's why they make erasers. There we go. All right, let's try that again. 10 degrees here, then he moves towards the mountain and measures an altitude or an angle of 22, thank you. We want to know how big h is. There's a distance in here that I don't know, which is this. What would you like to call this?
P.
P?
Gamma.
Any reason P?
Q.
All right, we'll use P. You were the first one to speak up.
Daddy, that's so funny.
Okay, the letters game is over.
Who made you in charge that you can tell us the letter game is over? It's not over till I say it's over. This isn't a democracy. All right. How many right triangles in that picture? Two. I'm assuming you're saying 2 and not P's.
Yeah.
Okay, good. So you're not wishing me peace.
Well, I'm wishing you peace.
I don't know what's worse, your sexy voice or her seal bark she just heard. Are you okay? Did you tear something? That was awesome. And the best part is we have it recorded. So we can turn that into a little sound file and just
Play it over and over.
put a little mix together. Just like a barking noise over and over again. Okay, there are 2 right triangles. We can assume that this distance is perpendicular to the other distance. The setup is bad. The solving is even worse. Okay, so I'm going to take you through it. Take careful notes. We're going to come back to this problem over and over again because we'll learn different ways to solve this type of problem over and over again. This is so nasty, I'm going to go to a blank screen.
Oh no, oh no.
Okay. So quick picture over here to remind us. Don't be scared.
Stop.
I'm gonna cry.
This has never killed anyone.
This makes me sick.
Okay, you ready?
Nope.
Too bad.
Wait, that's supposed to be P.
What? Oh, you're right. It is supposed to be P. Hold on.
Thanks, Mary. No problem.
Seal bar.
Oh my God, man, I'm gonna go listen to that.
You're so creepy.
Okay, let's start with the green triangle. This green triangle. What equation can we set up from that green triangle? Emily.
We can find the last angle, top angle.
We could.
Yeah, tan.
Do it. Shh.
68.
Beautiful. I will tell you that's not needed information, but for this method, that's not needed information. For later methods, we're going to be able to have to find that. That did not make sense whatsoever. Ignoring the 68, which again is useful information later, what equation can I set up within that green triangle? Let's use the 22-degree angle. Is H adjacent, opposite, or hypotenuse?
It's
Opposite. Is the P the adjacent or the hypotenuse? Adjacent. What function uses opposite and adjacent? Well, you get there eventually. So tangent of 22 degrees is equal to H over P or P over H?
H over P.
Well done. Here's the big question. Is that a solvable equation? No. Why?
Because
We have two variables.
Good, so basic rule of algebra, if I have two variables, how many equations do I need? Outstanding. Grace, your turn.
Oh.
Blue triangle. You with me?
Yeah.
What equation can I write from that blue triangle?
The cosine of 10
Is equal to?
is equal to 7 over whatever that line is, x.
But we don't, okay. I understand what you're trying to do, but
Oh,
is
7
that a right triangle?
No, so 7 plus p over,
That guy?
yeah.
But we don't want to use that guy, because I have no idea how long that guy is.
Tangent of 10 equals h over 7 plus p.
Tangent of 10 is equal to, go ahead.
7, h over 7 plus p.
Well done. Okay? It was fun, wasn't it? Oh, you just wait. Okay, that should be solvable. Two equations, two unknowns, should be able to knock this out and figure out what h and p are. We actually want to know what h is because I think that's what the problem asked, how tall is the mountain? We don't really care how far he's standing from the center of the mountain. The question is, how do I solve it? So I'm going to take this equation first and solve for h. So that p times the tangent of 22 is equal to h. Multiply both sides by p. Everybody's happy, yes? Too bad. Take this and do what with it? Right there for h. Tangent of 10 is equal to p times the tangent of 22 over 7 plus p. You might be tempted at this point to plug in the tangent of 10 and the tangent of 22 in your calculator. Don't do that. Leave it until the end. Then we'll get one big honking expression that you can plug into your calculator to get the most accurate answer possible. By the way, what's the reasonable answer for the height of a mountain? Anybody have a clue?
Meters.
Something around.
Let's keep going. What's next? How do I get p by itself? Nicole.
Multiply both sides by 7 plus.
Outstanding. 7 plus p in parentheses times the tangent of 10 is equal to p times the tangent of 22. Because if I multiply the right side by 7 plus p, it cancels at the bottom and just leaves you as p times tangent of 22. Okay? Distributive property. 7 times the tangent of 10 plus p times the tangent of 10 is equal to p times the tangent of 22. Nothing fancy yet. Take anything with a variable in it and move it to one side. Do you want to move it to the left or to the right? Do you want to stand up, sit down, or fight, fight, fight?
Left.
Right.
We're going to move it to the right. Why to the right? Because then I don't have to move that. So 7 times, easy. 7 times the tangent of p is equal to p times the tangent of 22 minus p times the tangent of 10. This one I'm not helping you with. What do we do next?
Factor out the p.
Factor out the p.
What?
This is called algebra.
What's that?
You might be, Emmett. In fact, here's a news flash. Everyone is dying. It's just a matter of when.
That's like so.
That's so true.
What's that?
Like so mood.
Why? Did you not realize you were dying?
No.
Did you think
it's
you
not
would live
something I
forever?
think about on a daily basis.
Okay, Subash, back to you. What do I do next since you started this mess?
Divide tangent of 22 minus tangent of 10 from both sides.
Beautiful. 7 times the tangent of 10 divided by tangent of 22 minus the tangent of 10 is equal to p. Yes! If you cancel those tangents of 10, I will come to your house and slap your dog. Do not cancel those tangents of 10.
What if you don't
Anybody do it already?
No.
You don't have a dog?
Yeah, I don't know.
You have a Cat?
No.
I don't have any.
Little
yet.
brother or sister?
Yeah.
Yeah.
It's my dog's.
Anybody an only child with no pets? Okay, good. Then I won't have to worry, because mom and dad would be next on the list. Mom, it's Shriti's at the door. Don't answer it! All right, plug and chug. Hey, just to make sure everything goes according to plan, let's slap some parentheses in there, just in case.
Oh, yes. I got it. Why? I don't think it's right, because that doesn't make sense.
But there's extra parentheses right
You are.
You are really rude, and I'm getting tired of it, so you will shut your mouth,
Dad?
or I will shut it for you. Are you clear? All joking
Is that Mary?
I'm tired of your negativity.
Mary,
I'm tired of your attacks and everybody. We don't have this conversation.
What do you
I
got?
did different. I just am so confused.
All right, what do we got? Other than a headache.
Oh, yeah, I think I went right. So I
Huh?
3.08.
3.08?
Yes.
1.82.
1 point. Oh boy.
I got it.
I got 3
What? 1 point or 3 point?
1 point.
Okay.
3 point.
3 point?
Actually, I didn't. I
You're
got
gonna make me do it,
I
aren't you?
got 2.87. No, I got 3.
May I?
Yeah.
Thank you.
Watch it.
Are you in the right mode?
Yeah, but I think I got it wrong.
You are in the right mode.
Oh yeah, there's a lot of parentheses.
Yeah, there are parentheses come all over the place. Tangent of 10, close parentheses, divided by parentheses,
In brother text.
tangent of 22, close parentheses, minus tangent of 10, close parentheses, enter 5.42.
Why'd you have
Well-
so many parentheses?
The calculator automatically puts in that parentheses. You got to close that parentheses before you throw in the other one. There's a parentheses there, there's a parentheses there, there's a parentheses there, there's a parentheses there. They're flying all over the place.
So wait, is it
What does that say? I can't read it. 5.42.
5.42?
P is equal to 5.42. You want to know the biggest insult to injury? That's not the answer.
Oh, yeah.
That's how far he is from the base of the mountain. Who cares how far he is from the base of the mountain?
Okay.
How do we find H?
So,
Put that in.
oh,
Rebecca.
so you use the tangent of 22 and plug in P.
Oh.
Take that answer which you stored on your calculator, multiply it by the, so you do answer, or whatever letter you stored it under, and multiply it by the tangent of 22, and we find that the height of the mountain is
2.19.
2.19 what?
I don't know.
Oh, 1.
Meters.
No, not me. No, wait, 2.19. So Mount Whitney is this tall? People have died trying to climb that height. You think they slipped and fell?
Kilometers.
Kilometers, kilometers. Do you have any idea how big a kilometer is?
It's a little less than a mile.
It's like 3
Okay, close enough.
Yeah.
Is that reasonable?
Yeah.
Yeah, for a mountain? Sure. That was fun, wasn't it?
No.
Everybody got that?
No.
What's the matter?
I tried the equation, not the 7 tangent 10 divided by tangent 22. I tried that 3 times and I keep getting something else.
Hit the mode button.
I'm in degree.
Sure.
Yeah.
Okay. Then I'll help you in a minute. The fun part is you're going to have to reproduce this. And then we're going to learn 2 other ways to solve that same problem.
Oh, God.
I will tell you this, the other ways are easier. But you don't have the information or the knowledge now to use the other method, so we got to stick with this. Okay. Assign the variables in the problem and set up 2 equations. Basic rules of algebra apply here. 2 variables, you need 2 equations. Distributing to each of those things. The distributive property, pretty basic. Solving a problem involving rational functions. Multiplying both sides by the same thing to get rid of it. Distributing, subtracting, adding, moving things around, factoring things out. That's all basic algebra that you should be able to do. Setting up the equations should be the hard part. This stuff is going to be tricky, but theoretically really shouldn't be. And try to keep your answer as exact as possible by storing numbers when you plug it back into the final thing. And lastly, ask yourself a question when you're done, does that make sense? Well, that seems reasonable for the height of a mountain. If you get like 2.19 meters, that's probably not reasonable. If you get 74 miles, that's probably not reasonable. Okay. So use a little bit of logic here. Is this fun?
No.
Shut up. All right, let's go back to the slideshow and see if we have another one. We got another one! Now, this is a practical problem here. When you're setting up the next dance, you're going to want to know, how high is that disco ball on the ceiling? Right?
Yes.
It's the first thing you ask yourself. You walk into the field house, there's a disco ball hanging, you say to yourself, how tall that disco ball is? Well, go get yourself a friend and figure it out. This is real world, kids. This is a skill you need to know. Try drawing a picture. I'll let you get frustrated with that for a little bit. That'll be done for you.
Oh, thanks.
If you draw your picture correctly, it should look familiar. Any luck?
Yep.
Get rid of that mountain. It should look identical to the mountain problem. Gym floor. Disco ball. Spot directly below the disco ball, perpendicular. Where's Rich?
Under the disco ball.
No.
No, Annabelle. I just told you.
Mary just told you that.
Doesn't it say under a disco?
Standing. Rich is standing 5 feet directly in front of Annabelle under a disco ball.
Right, but he's not directly under the disco ball.
He's directly in front of
He's directly in front of Annabelle, but he's not directly under the disco ball. That would be too easy.
Oh. Yeah, that is.
Yeah, that would be. Rich is over here. What do you want to call that point?
R.
How about R for Rich? Good. Where's Annabelle?
5 feet.
5 feet behind her. What do you want to call that point? A for Annabelle. Disco ball angle. For Rich? 50. For Annabelle? 40. How long is this? 5. H, X. We're not going to solve it, but it's the exact same problem. Set up two equations. Tangent of 50 is equal to H over X. Tangent of 40 is equal to H over 5 plus X. Go about solving your business. What's a reasonable answer for H? How high up on the ceiling do you think a disco ball would be?
Between 10 and 20.
Between 10 and 20 feet? That's reasonable. What would be an unreasonable answer?
3 miles.
3 miles. 2.19 kilometers. Okay? Good. And again, we're not going to solve that. I'll let you solve it. But again, the trick here is setting the problem up. We can do the same problem where we stick Rich on one side of the building, or at one side of the gym, and we put Annabelle over on the other side, and we both have them measure the angle of elevation. So we could have set up the problem like this. Disco ball, Rich, that's an R. Annabelle over here. Measure the angle of elevation, set up some equations, we're good to go. This one happens to be tucked inside the same one.
You just solved that the way you solved the other one?
Identically. Yep, just different numbers. Okey-doke.
This is fun, kids. Do that. And do that. And then come here. Yes. Okay. Day 8. We're done.
Your endeth the lesson.
I'm sorry?
Your endeth.